Good evening to all. Myself Saravanakumar, pichumani, working as assistant professor in the Department of Computer Science and Engineering at Sri Shanmuga College of Engineering and Technology, Salem. And today's topic of discussion goes to linear data structures. Normally, data structure is nothing but the study of structure of every data. And we normally categorize the data structures into two things. One is under linear data structures and non-linear data structures. In linear data structures, again we are dividing into arrays and linked list, and again we are bifurcating the linked list into stacks and queues. In non-linear category, we are having trees, graph, and hash tables. So why the name it is linear and non-linear? It means linear category means it is having a linear relationship or linear way of storing the data in the memory, and non-linear is opposite side, that is it is not having a linear relationship, it is scattered. Okay, so we need to have a link between one part with another part to have a connectivity. So all these trees, graph, and hash tables follow this kind of relationship, and list, stacks, queues, everything follows linear way of storing the data in the memory. Okay, so we will see among all this linear category, we are taking only the stack, and what is the idea behind the stack, and how a stack functions, and what are the applications of the a basic stack. Let us see the basic idea of a stack. A stack is an abstract data type that follows the principle of first in last out or last in first out, and it is mostly used in all programming languages, and it's a base for a language, and it is named a stack as it behaves like a real world stack. For example, a pile of plates, a deck of cards, or a stack of books, etc. So why it is called first in last out means, so when you are placing the books on a table, the first book we place on the table cannot be replaced or taken as a last book. So this is the principle behind the stack. So whichever object comes first, it can be taken as last, or whichever object comes last, it can be taken as first. So this is even take one more example, a pile of plates. So when you are stacking the plates one by one, so the very last plate comes as a first plate, and last plate comes as first plate, and first plate can be taken as a last one. Okay, so this is a basic principle behind the stack. Okay, let us see what are the operations that can be performed on the stack and how we are representing a stack. See, as we shown in the diagram, okay, stack is like a thing, and every element is placed one and above the thing. So this has to be followed, because we should not place the data elements on the right side or left side like that, adjacent. Okay, so you have to place every element above the previous element. So this way you have to follow. This is one hierarchy. Okay, and the way we are inserting or placing the element over the another one is called as push, and the way we are taking away the element from the stack, we call it as pop. That is the name given here. Okay, so we will be calling the name called push and pop for insertion and deletion respectively. Okay, let us see some more operations that can be performed on the stack. So one is, we already studied what is push and pop. That is, push represents insert and pop represents deletion. And apart from this push and pop, we are having another auxiliary functions, operations, like creating a stack, and we can check whether the stack is empty or not, or the stack is full or not. Okay, and if the stack is full, we normally we represent a term called overflow, and when it is empty, we will just represent by a term called underflow. Okay, and these are the applications of stacks. stacks plays a very vital role in all kinds of things. So one is called as first and more foremost application of stack in all programming languages is called function call. So whenever a function is called from the calling function to the called function or to the called function from the calling function, so the temporary operations till now we have performed in that particular logic is stored in the stack. So when we come back to the after doing all the operations and when the called function returns back to the calling function, and all these temporary values or temporary operations has to be performed routinely. So there stacks plays a very vital role. And for recursion, the same thing. Okay, so when the same function is called twice or calling by themselves, it is called recursion. And very important application of stack is like evaluating your expression and converting your expression. Expression normally we follow like an, a category of placing the operator in between two operands is called infix expression. And other two categories is called prefix and postfix. Okay, prefix is nothing but placing the operator as the first one, that is starting with the expression starts with an operator is called in prefix expression, and an expression ending with an operator is called postfix expression. So why we have these kind of categories means normally computers are not capable to evaluate your expression or doing calculations based on like infix one, let's say a plus b or b plus c like that. So whenever we give an expression, it will automatically convert it to the either prefix or postfix for kind of things, and evaluating that expression. So for example, if you are using like brackets, so whether this open bracket is compensated by closed bracket like that. So all this evaluating your expression, whether it is a valid one or invalid one, is all done by your stack. Okay, and parsing. So parsing is a vital role in your compilation. So the syntax for parsing is also is one of the application of stack. So we are having the, I have given one application in detail, that is how to evaluate an expression. So first thing is we need to empty the operand stack, that is we take the empty stack, and we are having a term called tokens. Token is nothing but whether it is an operator or operand, we call by a term called token. So examine the tokens one by one, and if it is an operator, do some operation. If it is an operand, do some operation. Okay, so first thing is if the first character is an operand, then we have to push into the stack. If it is an operator, then we need to follow the steps from A, B, C to D, or else. And if it is an unary operator, then we need to follow the steps from A to C. And we have to repeat the steps 1 to 6 till the stack is empty or we have read all the tokens. So once it is over, when you just read the tokens in the stack or popping out the tokens from the stack, it will give the evaluation. Like after the end of the things, if it is stack is empty, then it is a valid one, or else it is an invalid one. Okay. Now let us summarize. So we have seen what do you mean by stack and what is the role a stack plays in any computing area, basic idea, and how a stack functions, and some of the important applications of a stack in computing side. And thank you, and we will see about the next one called queue in detail like this in the next video. Thank you.